Now, in option D, we've been given the total distance like this versus the time, right? So on the y-axis, the vertical axis, we have total distance, and on the x-axis, we have time, and the graph originates at 0. The curve never goes downwards. So you might see here, it is bending a bit, but it's not coming downwards. It's still climbing up. The curve consists of segments with different slopes. Slope 1, slope 2, slope 3, slope 4, slope 5, slope 6. Right? Now, for a distance time graph, what does the slope represent? Exactly. Slope of distance time graph is rate of change of distance with respect to time, which is velocity. Right? So we'll try to understand the concept of this graph by keeping in mind the slope of the graph, which represents velocity. And I have divided this discussion into 4 different parts: phase 1, phase 2, phase 3, and phase 4. So, no, my bad. This is not velocity. This instead is displacement. So if you're making a note of this, please do make this correction. It's not velocity, it is displacement instead. So we have phase 1, O to A. Then we have phase 2, which is from A to B. Phase 3 will be from B to C, BC. And then CD, which represents phase 4. So we'll have to make note of all the points in these 4 phases. Starting with phase 1. So what happens in phase 1? From O, which is the origin here, the graph has an initial rise, which is very steep. And this implies that distance increases quickly with time. So within a short span of time here, distance has gone very high. Okay. And what does this mean in turn? This means that the object has started moving immediately after the observation started. And for the distance along OA, the speed is relatively high and motion is continuous because there is no break at all. It is continuous. Okay. So if you were to compare, make an analogy here, it would sound like this. You start working fast as soon as the stopwatch starts. Walking fast, more distance in less time, more distance in less time. Stopwatch starts, t is equal to 0. Okay. Moving on to AB now, which is phase 2, what we see is a very gentle rise of the slope. Unlike O to A, where it was really steep, A to B is not that steep. It's gentle. The line still rises from A to B. It's not going down, but it's less steeper. So since it is still rising, the distance is definitely increasing. But since it is less steep, the rate of increase is slow. And what would this mean? This means that the object is still moving, the speed has reduced, and there is no stopping yet. To draw an analogy here, we can compare this after walking quickly from O to A. We slow down from a jog to a walk. So O to A, we were jogging, and A to B, we slow down from a jog to a walk. So we were jogging from O to A, and then we just slowed our pace from A to B and started to walk. Now, if we move on to the next one, which is phase three, from B to C, what we see again is that the rise is more steeper here, as we had in O to A, and there is a sudden increase in the slope as well. Therefore, distance rises faster again. And what would this mean? This means that the speed is increasing again. Possibly it's due to acceleration. Motion is, well, see, this doesn't make sense. Possibly acceleration occurred earlier. My bad. I stand corrected here. Please don't make a note of this one. Okay. Motion is still in the same one dimensional line. To make an analogy here, we could say that we speed up again after slowing down, meaning 0 to A, we were jogging, A to B, we were walking. So jog to walk. And then maybe from B to C, we started to jog again. We increased the pace, or maybe we started to run again for that matter. Okay, right. So that's what's happening in the graph along BC. Now, the last phase, phase four, from C to D, we see now, see, C to D, some of the textbooks might give C to D as a pure flat line. Some of them might be giving you a less steeper line. Now that the explanation varies accordingly. Okay. Now you know what it means when the line is flat. So if line CD is flat, what would that be? What would that mean? Let's try to understand that. So the phase four is nearly flat. It's nearly flat, or the rise is very shallow, and the line becomes, oops, yeah, the line becomes almost horizontal, right? The line becomes almost horizontal. So if CD is almost horizontal, it means rate of change of distance with respect to time. My bad, it's not velocity, it is distance. So rate of change of distance with respect to time is almost zero, which means velocity is almost zero, which means the object is slowing down or is almost at rest. Okay. So the object is either moving very slowly if this is less steep, or if this line is CD is almost parallel to the x-axis, parallel to the time axis, it means that possibly the object is at brief rest, or it is becoming, if the line is becoming parallel to x-axis. So if less steep, it is moving very slowly. If it is parallel to x-axis, the object is briefly at rest. Okay. And distance covered is almost constant in this case. Now, if you were to make an analogy here, you almost stop, maybe taking tiny steps. So jog, walk, run, tiny steps. One more time with me. Jog, walk, run, tiny steps. Okay. So this takes us to the summary, which is distance time graph, slope is velocity. Oh, sorry, slope is speed. Steep slope means high speed, gentle slope means low speed, horizontal flat or flat line means speed is equal to zero. So the option D represents higher speed, jogging, lower speed, walking, higher speed, running or jogging again, zero or near zero speed, object is either moving very slowly or is at rest. Which leads us to the conclusion saying that option A does represents what? Represents one dimensional motion. B, I don't personally agree with the with the given graph and have justified my disagreement with that. But going with the key of JE main, This B is also correct. It also represents one dimensional motion. C is incorrect. D also represents. The correct option would be A, B, and D. Okay. Now, yes, I'm pretty sure that some of us might have problem with the steeper slope here. Let's try to understand that part in detail. Okay.